Hi guys, so today we're going to be doing some geometry review and we're going to look at special right triangles. So if you remember, you guys learned about these back in geometry. There were two types of special right triangles. There was 45-45-90 and 30-60-90. And the reason they were special is because they had a certain ratio that was common for all of them, no matter what the sides were. So the first one is the 45-45-90, and that was also called an isosceles right triangle. And the reason for that is because, isosceles triangles have two sides that are the same. And because it was a 45-45-90 triangle, if one angle was 45, because they have to add up to 180, the other had to be 45. And the angles across from each other have to be the same number. So if this side was 1, the other side had to be 1. And then if I did Pythagorean theorem, my missing side had to be the square root of 2. So these always followed the ratio, no matter what that side was. If this side was x, the other side across from 45 was x, which means across from the 90 was x times the square root of 2. So what I do for my isosceles right triangles is I always keep them in a chart. And I have 3 columns for 45, 45, and 90. And then I fill in the ratio. And my ratio for these is x, across from 45 is x, across from 45 is x, and across from 90 is always whatever that side was times the square root of 2. Then the other one that we had was a 30-60-90 triangle. In my 30-60-90 triangles, the 30 is the smaller angle, which means across from the 30 is the smallest side. Because if you guys remember, the smallest side is always across from the smallest angle. So across from 30 is 1. If across from that, across from 60, that I have to have the square root of 3, and then across from 90 had to be 2. So again, with a ratio, that would always be x times the square root of 3, and then 2 times x. So if that side wasn't 1, let's say that side was 3, then across from the 60 side would have to be 3 times the square root of 3, and then across from 90 would have to be 2 times 3, which would be 6. So it doesn't matter what those sides are, they follow that same ratio. And again, I'm going to put that ratio in a chart. So I've got my 30 side, my 60 side, and my 90 side. And remember, 30, it's what's across from 30, what doesn't touch 30. So that's my x side. Across from 60, that's x times the square root of 3. And then across from 90, the biggest side, is 2 times x. And again, remember, the biggest side's across from the biggest angle. Square root of 3, that's the middle one, because the square root of 3 is bigger than 1, but it's less than 2. So we're going to use those ratios to solve some triangles. And we can solve triangles if they're right triangles in that ratio and they only have one side given. So we're going to look at this first one. So I know that this is going to be an isosceles right triangle, and even though it's not marked, it's going to be 45-45-90, because if those two sides are the same, the two angles have to be the same. So they both have to be 45. And if one side's 3, well, then the other side has to be 3. Again, if I want to use this chart here, I've got 45, 45, 90, and my ratio is x, x, x square root of 2. I'm going to fill in what I know to this chart. Across from 45 is 3 on both sides, which means that my x is 3 because it's in that same little column. So x equals 3. So everywhere there's an x, I fill in 3. So across from 90 is 3 square root of 2. And I just solved that triangle. Alright, so let's look at the second one over here. This one's a 30-60-90 triangle. Okay, the 60 is not labeled, but again, I can subtract from 180 to get my missing side. And that's actually the letter B. That's not actually a 6. And we're going to try and solve for side B. So solve for that missing side. So what I'm going to do is I'm going to fill in what I know on my chart. So I've got a 30-60-90 triangle, and my ratio for 30-60-90 is x times the square root of 3, and 2x. I'm going to fill in what I know. I know that 5 is across from 90, so 5 goes in the 90 column. So now what I need to do is I need to solve for x. Now this isn't as easy as the other one was, because the other one, all you had was x equals 3. On this one, though, I know that 2x is equal to 5. So I need to solve for x before I can plug it in. And all I have to do is divide by 2. So I get that x equals 5 over 2, or 2.5. We're going to leave it as 5 over 2 just because we're going to see a lot of improper fractions when we work with radians. So I'm going to fill in this column as 5 over 2, which makes my last column 5 over 2 times the square root of 3. And I'm going to write that as 5 root 3 over 2. So now that my chart's filled in, I just need to figure out what my question's asking for, and it wants me to find what B is. Okay, so B is that bottom side, and it's the side that's across from 60. So my answer is the one that's in the 60 box, which is 5 root 3 over 2. Alright, my next one, it's a 45, 45, 90 triangle, and it's telling me to find side XZ. So it's telling me to find my hypotenuse here. Now this one can be kind of tricky if you try and do it too quickly. Okay, so you might see that square root of 2 on there and know, oh, my ratio is x root 2, so this has to be 5. If you think about that, though, that doesn't make any sense, because my leg of my triangle is 5 times the square root of 2, which is a bigger number than 5. There's no way for 5 to be my hypotenuse, because that has to be the biggest number. So I'm going to fill this in with my chart. I've got 30, 60, 90, so that's x root 3, and 2x. And I'm going to fill in 5 root 2 to the column it belongs to. And I just filled in the 30, 60, 90 chart when I meant to do 45, 45, 90. Sorry, guys. Whoops. So there's 45, 45, 90, and that's x root 2. Sorry about that. So if I look on here, 5 root 2 is across from my other 45-degree angle. So 5 root 2 is x. So that means my other side is 5 root 2, so across from the other 45. But then my hypotenuse, x, gets replaced with 5 root 2. But then x is still multiplied by the square root of 2. So 5 root 2 times root 2 is actually 5 times the square root of 4. And we know that that's the same thing as 5 times 2, which is 10. So my missing side here, the hypotenuse, is actually 10. So we need to make sure to be careful and not just fill these out quickly, or we might make a little mistake like that. Alright, so my next one here, we're going to solve for side y, which is my hypotenuse. And this next one actually is a 30, 60, 90. I'm not going to mess it up like I did that last one. So I'm going to fill in my chart. Here's x root 3, and 2x. And I'm going to fill in what I know. I know that 5 is across from 60. It doesn't touch 60, so 5 goes in that column. And again, I need to solve for x. So I'm going to write down what I know down here. I know that x times the square root of 3 is equal to 5. So I need to get x by itself, and I do that the same way I would do if I had 5x equals 10. I need to divide by what's with the x, and in this case, it's the square root of 3. So that means that x is equal to 5 over the square root of 3. Now, if you guys remember, you used to have to get that square root out of the bottom of the fraction. For now, you actually don't need to do that. It's okay to leave the square roots in the bottom. Now, it is kind of helpful to know how to do that in case you ever see an answer choice that is what we call rationalized. Rationalized is when you get that square root out of the bottom. So it's good to know how, but you don't have to if you're just writing your answer. So I'm going to leave this as 5 over the square root of 3. And now that I know what x is, I can find my 90 side, which is what I'm looking for. Because what I was looking for this whole time was actually the y, which is across from 90. And that's going to be 2 times 5 over the square root of 3. And remember, that's 2 over 1. So what I'm really doing is 10 over the square root of 3. And that's my missing y side. Okay, if you wanted to rationalize the denominator, you could, in case you can't remember how to do that. I multiply by the square root of 3 on the top and bottom. And I multiply straight across the top. And the square root of 3 times the square root of 3 is just 3. So that's also the same answer. So that would also be correct for your x. So it's okay if you do that, but you don't need to. It can save you a little bit of time. Alright, so my last one's a little bit of a similar type question. I'm going to have to use a similar process. And what I'm going to do is make my chart again. This one is an isosceles right triangle, which makes it 45, 45, 90. So I have x square root of 2. And I'm going to fill in the 7 where it belongs. So 7 is my hypotenuse. It's across from 90, so it goes in the 90 column. And again, I need to solve for x. So I'm going to say that x root 2 is equal to 7. And to get the x by itself, I'm going to divide by the square root of 2. And I get that x equals 7 divided by the square root of 2. So then I'm just going to fill in those columns. I don't have to rationalize it. And I'm looking for y, which is across from that 45-degree angle. So that's my answer. Alright, so that's a little bit of a review on special right triangles, and we're going to do a little bit more geometry review before we start to learn some of our new trick things.